Welcome to our second session of the Pulley. Now I want to discuss the problems. Problem number 1. To raise a load of 240 newtons, a worker applies a force of 130 newtons to the mobile extreme of the rope to raise the load. What is the efficiency of the pulley? First of all, we need to identify the problem. So we can start working with a small diagram showing the pulley. In our case, this pulley has a load of 240 newtons. And also we have a pull force, we go downwards as well, of 130 newtons. Okay, so it's going downwards. Our pulley, it's not mentioned in the problem, but it measures 12 centimeters of diameter. Okay, so now we can identify what's going on. What data we have? We have the diameter of 12 centimeters, so we know already the radius of 6 centimeters. We know also that the resistance force is 240 newtons, and the pull force is going to be 130 newtons. So what's next? Identify the actual mechanical advantage. So the value of this is going to be the force required divided by the pull force. This is 240 newtons over 130 newtons. That is giving us the answer of 1.85 of the actual mechanical advantage. Next step, we need to identify the mechanical advantage, but now is the ideal mechanical advantage. So that value can be identified as the diameter of the pulley by the radius of the pulley. That means 12 centimeters over 6 centimeters. That is giving us ideal mechanical advantage of 2. At last, but not least, the efficiency can be calculated by dividing the value of the actual mechanical advantage over the ideal mechanical advantage. And we multiply times 100 because it is usually, the efficiency usually named and measured with percentage. So we have 1.85 over 2 times 100 is giving us 92.5% of efficiency. In the next problem, let's read along. If a pulley system can lift a 200 Newton load with an effort force of 52 newtons and has an efficiency of almost 100%, how many ropes are supporting the load? Well, we're talking right now about a pulley system. We don't know how many ropes we have, but we have a load that's going to be 200 newtons. And also, even lift by a system of pulleys that we don't know how many ropes are supporting the load. But we know the effort force is about 52 newtons. Okay. So to calculate this, the quantity of ropes, first we need to know what data do we have. We have the resistance force, which is 200 newtons, and the pull force, which is 52 newtons. Our ideal mechanical advantage can be measured by the division of the resistance force over the pull force, which is 200 newtons over 52 newtons. That has given us the answer for the ideal mechanical advantage of 3.85. So we may consider around the number of 4 ropes for this answer. How many ropes? 4. You cannot use 3.85, so you round it to 4. 4 ropes. For problem number 3, we're finding the pulley system on the right lower image. Assume that this pulley system is an ideal machine. How hard will you have to pull the rope to lift 120 newtons load? How many meters of rope will you have to pull out of the system to lift the load 1 meter? So let's start with the data we have. We have the resistance force, which is 120 newtons. We don't know how much is the pull the pull force. We have the resistance distance, which is going to be 1 meter load, 1 meter that we need to upload the load. But we don't know how much rope we need to pull to lift it up 1 meter. How can we start? First of all, we need to go back and understand the ideal mechanical advantage formula, which is going to be the resistance force over the pull force. In this case, the ideal mechanical advantage is going to be equal to the number of ropes that we have in the system. In this case, we have number of ropes equal to 4. We can see on the image on the right that we have n equals to 4. That's the number of ropes. If you draw a line, a horizontal line over the system like this, it's already done, you will cross over 4 ropes. That's why number 4 is the number of roadway crossing. So what's next? We just isolate the pull force of that formula, or the ideal mechanical advantage. I will have 120 newtons over the value of mechanical advantage, which is 4. That is giving us the answer of 30 newtons. Next step is going to be to remember the same formula. It can be applied by the ideal mechanical advantage. It's going to be the division of the distance of the pull force over the resistance force, in this case, the distance of the required force. That's 1 meter we need to raise the load. So you need to isolate the distance of the pull force like this, and we get the answer of 4 meters. What can we conclude of this? That to lift a load of 120 newtons and rise it up 1 meter, you need to pull with 30 newtons, 4 meters of rope to get this load raised by 1 meter. So that's the way to conclude what's going on. So what's next? Now your turn to solve some pulley problems. So thanks for watching. And feel free to go back to this video as a reference how to solve those problems. Thank you.